Hello again, this is Scott, and this week we're going to talk about elasticity. So elasticity comes in many different forms, but generally what elasticity is trying to understand is how will a buyer or a seller respond to price changes? If I'm a buyer, just get some basic intuition, and the price of a Shamrock Shake doubles, I may change my behavior on what I'm going to buy pretty substantially. But if I'm the buyer of insulin, insulin is required to live for diabetics, and there is no substitute. If the price of insulin suddenly doubled, I may not change my buying behavior very much. I may keep buying. So what we're going to be looking at is how do buyers or sellers respond to various types of changes? We may change the price of the good. If I change the price of insulin, how will that impact my insulin purchases? We may change the price of a related good. So if I change the price of Coke, what does that do to Pepsi? We may change income. We may change the price for the seller. So there are various types of elasticity. Then what we're going to do is we're going to tie this change to the end and say, well, how does this concept actually get used in business or in government? So why do we care that there's some goods or services that are more or less responsive to others? So the first elasticity we're going to be talking about is simply called the elasticity of demand, but it could just as easily be called own price elasticity, because what we are going to look at is how, when I change the price of one good, how does it impact the amount of that good I am buying? We're measuring the sensitivity of a particular good to a price change of that same good. Now, as we mentioned last slide, some goods are more responsive than others. The more responsive, the greater the response, the more elastic it is. The less response we get, we call that inelastic. So we're going to start off building some intuition. And what we're going to do is we're going to try and say, let's pretend there are two goods. I'm a wealthy person. I flip houses for a business, and I like Tootsie Rolls, and I buy houses. And every day I eat 3 Tootsie Rolls, and the Tootsie Rolls sell for $0.25 each, and I buy a house every other week to flip it. If that's the case, we want to know how responsive these goods are to a price change. Well, one way we can measure response is if we set the prices that change equally. Now, this is not correct, but what we're going to do is we're going to build some intuition here. One thing we could do is we could standardize the price change and look at the response. Let's see what that looks like. So let's say we change the price by a standard amount. A standard amount could be $1. So if we change the price for a Tootsie Roll from 25 cents and raise it by $1, it's now $1.25. If I change the price of a house, which was $250,000, now it's $250,001. You can see pretty quickly that this dollar change isn't a real good way to measure that response. Why? A dollar change on a Tootsie Roll is a huge impact on the price of a Tootsie Roll. A dollar impact on the price of a house is tiny. So what we need to do is not just look at a standard change, but we want to look at a standard proportional change to see what the response is. If you're not clear what I meant by proportional change, think of the Tootsie Roll for a second. If you went from 25 cents to $1.25, that is $1 more. $1 divided by a quarter, that's a 400% price change. Now I recognize what I have here is something a little bit different, which we're going to get into in a second, but $1 divided by 250,000 is just a tiny fraction. So the dollar change was not proportional for both of them. And as a result, we really can't say that $1 is the right unit of change to look at responsivity. So we're going to need to come up with a better measure. In a second, I'm going to explain how I got these numbers, because as economists, we like to do things just a little bit differently. So what is the measure that we use? For us to examine the elasticity of demand, what we're going to look at is how much of an impact does a 1% change in price have on that good? So if I change the price of good X, how much more or less of good X am I going to buy? Now, you'll notice we have an absolute value sign here. What's the absolute value sign for? Well, we know from the law of demand, every time I raise the price, you're going to buy less of it. And every time I lower the price, you're going to buy more of it. So we're not going to use the sign at all because we know the law of demand says these are negatively and inversely related. It's sort of condescending for me to say, hey, I'm raising the price. You realize you're going to buy less of it, right? So we don't talk like that. We just drop the absolute value. What that dollar price change we had before was a very disproportionate percentage in terms of the Tootsie Roll, which was a very low price object, and a house, which was a very high price object. So we're going to standardize it. And notice the key here that we're both talking about the price of good X. If I change the price of a Tootsie Roll, how much more or less Tootsie Rolls am I going to buy? If I change the price of a house, how much more or less houses am I going to buy? This right now, where they're both X's, is the price elasticity of demand. That's going to change in a little bit. If we're going to calculate the percentage change of a price, well, then what we need to do is we need to standardize it over some price to make it a percentage. But the question is what price should we use as the denominator? You'll remember that the percentage change in price of the Tootsie Roll we had as 133%. How did we get that? We know the price change went from 25 cents to $1.25, and the price went up by $1. What denominator should we use? Should we use the old price, the new price, or something in between? Those are our options. If you use the original price going from 25 cents and you have $1 increase, that's a 400% price change. If you go from the new price, then the dollar compared to the $1.25 is only an 80% price change. But if you use the average price, it's 133%. Why are we using 133%? Well, one of these, and only the midpoint formula, would give you the same number whether you are going from 25 cents to $1.25 or $1.25 back to 25 cents. By using the midpoint, you're looking at the rate of change relative to what's happening in the middle. Think about it this way. You're driving a car and you go from 50 miles an hour to 100 miles an hour. You have 100% change in your speed. If you then go from 100 to 50, you now are doing the exact same relative change of 50 mile an hour change, but it's only a 50% change. Well, that's kind of confusing to think about direction. But if you went from 50 miles an hour to 100 miles an hour, and that's a 50 mile an hour change over the midpoint of 75, or going from 100 to 50 over the midpoint of 75, your percentage change stays the same. So we don't get this distortion about whether it's going from small to big or big to small. We're just using the midpoint. And things tend to get more easy to understand if we use this midpoint formula. You're going to see a lot of formulas going on here. But really, once you do this formula 3 or 4 times, it's the same formula over and over and over again. So the elasticity of demand is the absolute value, because we know it's the law of demand. This is going to be a negative relationship, so we're just not even going to say it. We're going to use the absolute value. And we want to know what the percentage of quantity demanded changed is when I change the price of that good. So this is just restating it in English. It's the percentage change of quantity demanded for good X divided by the percentage change of price for good X. In order to get the percentage change, we need to know what the change is. So what's the new one? What's the old one? That's the change over the average. So this crazy formula will break down, and we'll look at the same formula, whether we're talking about change in demand or change in price, or in a little bit change in price of another good or change in income or whatever. It's going to be the same formula over and over and over again. So I'm going to calculate the elasticity of demand for the Tootsie Rolls when the price went from 25 cents to $1.25, and when I went from buying 3 Tootsie Rolls a day to buying 1 a week. The top part of the formula wants us to figure out the percentage change in quantity demanded. First, I have to figure out, how did the amount I bought change? Well, I should use the Q new minus Q old, and I'm buying 1,043 less than I used to. Well, now I need to take that and make it a percentage. So what I'm going to do is I'm going to take the average of those two. So I'm going to take 1095 plus 52 and then divide it by 2. Once I have that, I know that my average was 573 and a half. Taking one divided by the other, I am at negative 1.81 or negative 181%. Because we're using the midpoint. Now the price change. The price is now $1.25. It was 25 cents. The price changed by $1. What was the average price? It was a quarter and then $1.25. You add those two together, that's $1.50. $1.50 divided by 2 is 75 cents. The price change was 1.33 or 133%. Now I can just plug in this number, because it's this number, because it is the percent change in quantity demanded in my numerator. And I could plug in this number, which is this number, in my denominator, and one divided by the other, take the absolute value, and I could get my elasticity. I suggest try this example with the housing change, and you'll see it's a very small change. And then the worksheets that we do in class or are online, walk through example after example, making sure that you understand how this works. The sooner you do this and the more practice you get, the better. This is one chapter where students typically either ace it or they bomb it. If they do enough practice, it becomes routine and they can fly through this. Without enough practice, there are numbers flying everywhere. So we just calculated that the elasticity of Tootsie Rolls in this example is 1.36. You may be looking or thinking to yourself, what does this mean? Why do I care? And maybe you don't care, but here's the interpretation. For the manufacturers of Tootsie Rolls, every time they raise the price of their product by 1%, they could expect to lose 1.36% of their sales. People are going to respond and shift away from buying their products in a greater proportion than what the price change is. Two things to notice. One is this number didn't have a negative sign, and I said as they raise the price, people are going to buy less. Remember how there's a negative sign in here, but not on this number. It's expected that you recognize that these are inversely related. The other thing is that when this number is bigger than 1, it means that the numerator is bigger than the denominator. So if it's bigger than 1, what it means is that every time you change the price by 1, supply and demand is going to change by more than that. You're having a bigger response. Now we're going to call that bigger response elastic. If I change the price by 10% and more than 10% of my buyers change their behavior, we're going to say that's a greater than proportional change and it's elastic. If I change my price by 5% and a smaller than 5% change, it's relatively smaller than the price change, we're going to call it inelastic. And if they're proportional, we're going to call them elastic. We are going to call the product elastic if the percent change in quantity demanded is bigger than the percent change in price. So no matter what this is, and the elasticity measure is the numerator over the denominator, and the output is really where the denominator is just equal to 1, but the denominator could be 2, 3, 4, 5. If I change the price by 5%, if the change is more than 5%, so 5+%, so if it's 5.01, 6%, 7%, it's an elastic change. If I change the price by 5% and this is something less than 5%, so who knows what, 4.9%, 2%. If I change the price by 5% and I only lose 1% of my sales, people aren't substituting away. They're not changing their behavior. We're going to call that inelastic. And if they happen to be exactly equal to each other, we're going to call it unit elastic. So what are some reasons why people may change their buying behavior? Well, one is if the price of the good I want to buy goes up, if I have lots of other options, I'll just switch away from buying Coke to buying Pepsi or buying a million other colas that are out there. So the more substitutes I have available, the greater possibility I have for a response. The greater possibility I have for a response, the more elastic I am for that product. If the good is more of a luxury versus a necessity, I could just simply say, you know what, I'm going to change my buying behavior. I don't even need to substitute. I may just stop buying the product. That's not an option if it's a necessity. If it's a drug you need and there are no other options out there, and if you don't take it, you're going to die, you're likely going to keep buying. You're not going to change your behavior. The other two are percentage of the budget. If I go to the store and I need a pencil, and a pencil is 25 cents, if I then go to the student bookstore and I need a pencil for an exam that day and they have it and it's 50 cents, fine. I may just pay the extra 25 cents, even though proportionally it's a really big price change. Why? Because it's a quarter. It's not really worth it for me to drive all over. However, if the price of my mortgage suddenly doubled, if my mortgage went from $1,000 a month to $2,000 a month, even though it's the same price change, it's doubling, that $1,000 has a huge impact on my budget and I'm forced to go out and look for alternatives. The more expensive the item is, the more I'm going to have to look for alternatives. Finally, time constraints. If I need to buy a pencil because I have to take an exam in 10 minutes, I'm going to buy the pencil no matter what the price is. I also do saltwater reef aquariums. So one day I had my tank was having a leak and it was about 5 minutes to 9 o'clock. There's a hardware store right around the corner. I know they have the part I need and I know it's about twice as expensive as Home Depot, but I ran in and I bought it. Why? Because I didn't have the time to go somewhere else. If you need something and you need it immediately, you're going to be more inelastic. If I have more time, if I knew I had a week to buy a part, I could order it online. I have lots of other choices. Depending on your time constraints, the less time you have, the more inelastic you are. Over time, things become more elastic. So let's take these determinants of price elasticity one at a time. So remember, elasticity is a measure of responsiveness. So the more choices people have, the more likely they are able to respond when a price changes. So the greater the number of substitutes is the number one factor on increasing elasticity. If there aren't places for you to switch from buying one good to another, then there's no response that you can have. The greater the number of substitutes, the greater the elasticity. A luxury versus a necessity. This is if diamonds triple in price, you may just simply say, all right, I'm not going to buy anymore, and your behavior, the number that you buy, changes. But if a drug that you you need to survive changes in price, then you may keep buying it, whether it's a luxury or a necessity. Now, we will probably be discussing someone called a pharmacy bro who took a pill that was very cheap. I think it was about $13 a prescription, and then bought the patent on it and raised the price to almost $1,000 overnight. Well, why did he do that? He knew that if he has the only drug and people need it to survive, they're going to keep buying it. In economics, we are studying the tendency for people to keep buying a product, but obviously we want to be talking about morals and values as well when we talk about this. The percentage of one budget on a small item, you really don't feel the impact. So if a Tootsie Roll went from 25 cents to 30 cents, okay, it's not a real big deal in the grand scheme of things. If your rent went from $2,000 to $4,000, it's a substantial impact. The bigger the price, the more elastic you're going to be to look for substitutes. The last determinant is time. And the way it works is simple. If you have a lot of time, you could search for other options. You could search Amazon. You could search all sorts of places to try and find solutions. But in the short term, you don't have as many choices. So if the price of gasoline suddenly triples tomorrow, your car still needs gasoline. In the short run, you're going to need gasoline. In the long run, you could start to think about hybrid cars or motorcycles or other forms of transportation. But in the short run, you're stuck with less choices. Graphically, what does elastic demand look like? Elasticity is the elasticity demand is greater than 1, and that was the percentage change in quantity demanded over the percentage change in price. So what we need is the percentage change in quantity demanded to be bigger than the percentage change in price. Here we have price going up by 10%, so this has to change by more than 10%. In this case, it's changing by 20%. Inelastic demand curve, now this isn't always right, but think of it as sort of more vertical, even though a straight line is going to have an elastic, an inelastic, and a unit elastic segment. But the more vertical it is, you can think of it as price went up by 10%, but they only lost a small fraction of what they were going to sell. They lost 4%. When this number is smaller than that number, then the elasticity demand is going to be less than 1, and we have an inelastic demand. Unitary elastic is when these two things are exactly equal to each other. If one goes up by 5% and the other decreases by 5%, or 10% and 10%, they're exactly the same. We call it unitary elastic. You could have a completely inelastic, and we call that perfectly elastic, which is no matter what the price changes, you're going to keep buying that product. Now, you may think of a prescription that you absolutely need to live, that there are no substitutes around, that if they raise the price, you're going to keep buying the same amount. But as a healthcare economist, I would say that even medicine has some degree of elasticity. Why? Because people start splitting some pills even if they can't afford it at some price. Theoretically, you could have a perfectly inelastic demand curve where you raise the price and people don't change their buying behavior at all. You could also have perfectly elastic, which is the exact opposite of inelastic, which is you'll buy all you can at a given price. But if the price goes up a little bit, you change your behavior and you don't buy any from them. So that's what we're going to use when we start talking about perfect competition. When we talk about perfect competition, I can buy a potato from anywhere, and there's a going rate for potatoes. And if someone tries to raise the price a little bit, I'm not going to buy it from them. I'm going to buy it from somewhere else. I'm perfectly elastic demand. I'm willing to substitute 100% of my demand from even the smallest price change. So this just captures the various elasticities, what they mean, and the terminology. These are the 5 types of elasticity for price elasticity of demand. So how do firms use elasticity? Well, if you think about it, a firm's goal is to maximize profit. We're going to get into firm maximization problems actually in about 2 chapters. The firm's goal is to maximize profit, which is maximizing the amount of money they bring in and minimizing their costs to get to that spot. If you think about it, that's total revenue minus total costs. And total revenue is the amount of money you're bringing in. If I sell 100 things at $4 each, I should have $400 in my cash register. It's the amount of money I bring in per unit times the number of units transactions I have. If elasticity is elastic, then if I raise the price by, say, 5%, I'm going to lose more than 5% of my sales. So when I raise my price, my revenue is going to fall. The opposite's also true. If I lower my price, my revenue is going to increase because I'm going to sell to a lot more people. Firms have to maximize and understand how this works. So we're going to look at a couple graphs to visually understand what's going on here. Assume for now that the price of the good is P1. If this is the price you get for each good, and this is how many you sell, then this box, price times quantity, is the amount of money you're bringing in. If the price falls to P2, then you're going to sell more. You're going to get that amount for each good. and you're going to sell this many Q2, and you get that box. So by lowering the price, what is going on? By lowering the price, you are losing that extra revenue on all those sales, but you are going to gain this huge box of revenue. The yellow box is bigger than the red box. So if it's elastic demand, lowering the price means you're going to lose some money on some of your sales, but you're going to more than make up for it on new sales. So if demand is inelastic, think about what that means. It means I could raise the price and people aren't going to substitute away from the product. Maybe there aren't substitutes for it. Maybe they don't have time to substitute. So if you think about it intuitionally, going from price A to B, when you raise the price, yes, you are going to lose some sales. You are going to lose this little box of sales, but you are going to gain this huge price increase on a majority of your sales. You raise the price by 5%, you're going to lose maybe 2% of your customers, but your revenue is going to increase by more than 5%. So that's what we have going on here. So this just summarizes when elasticity is greater than 1, so it's elastic, when elasticity is less than 1, and when elasticity is unit elastic, what a price change does to total revenue. The next elasticity that we want to talk about is called cross-price elasticity. And the formula looks almost the same except these tiny little subscripts. And what these subscripts are trying to say is, I want to know what happens to one good if I change the price of another good. So it could be, if I change the price of hot dogs, what happens to the amount of hot dog buns that are purchased? Or if I change the price of hot dogs, what happens to the amount of chicken or hamburgers that are purchased? So we want to know how goods are related. So the real key here is to notice the subscripts. Besides the subscripts and the intuition, everything else is the same, except that when we talked about elasticity of demand, we said the law of demand told us that whenever the price of something went up, we bought less of that same something. So we took the absolute value. But here, we can't take the absolute value. As we learned in previous chapters, a substitute is if I raise the price of Coke, people are going to stop buying Coke and buy more Pepsi. An increase in price of one good causes an increase in demand for the other good. Whereas a complement, if I raise the price of airfare, I'm going to buy less hotels. That's a negative sign. The sign is what we are looking for. So this just summarizes it. If the elasticity is a positive number, we know they're substitutes, Coke and Pepsi. If the elasticity of cross-price demand is negative, they're complements. That's airfare and hotel. So far we talked about price elasticity of demand, which is really if you change the price of the good, how much more or less of that good are you going to buy? Then we talked about cross-price elasticity, which is if you change the price of a related good, how much more or less of the other good are you going to buy? Now what we're going to say is, well, if your income changes, how much more or less of the good are you going to buy? This is just quantifying what we calculated in an earlier chapter about defining whether something's a normal, inferior, or neutral good. It's going to be the exact same thing. We're going to calculate it based on the percentage change of income. Same formula, same everything else. Just like before, we're going to quantify it. Some examples of normal goods are if your income goes up, what are things you're going to keep buying or buy more of? So if suddenly I got paid twice as much, I may go to the restaurant more often. I'm a foodie. I like foods. I'd go on vacations more. I'd buy more movies. What are inferior goods? Well, this is if my income went up, what am I going to buy less of? I'd buy less ramen noodles. I'd buy less hot dogs. For me, I'm only buying hot dogs because I can't afford steak or lobster. What are neutral goods? Neutral goods are if my income increases, I'd buy the same amount. Even if I suddenly got double my income, I'm not going to run out and say, woohoo, I'm buying a lot more toothpaste. This is the way to kind of keep things categorized. And again, we're just quantifying the numbers that we had done in a previous chapter. Now, the book talks about elasticity of supply, which is really talking about the firm's ability to respond to price changes. And while I think it's an important topic, I'm choosing not to cover it. Remember, we always talk about opportunity costs. When we cover one thing, it means we don't have that time to use for something else. But here's the only thing I want you to know on elasticity of supply is that firms do respond to price changes. And there are some things they can do and some things they can't. So we could have a perfectly inelastic supply curve. For example, the number of Pablo Picasso paintings in the world isn't going to change. We may be able to change the number of prints or copies, but the originals aren't going to change because Picasso is dead. Some things we can change. So if the Super Bowl comes to Minnesota, there's a fixed number of seats in the stadium. That is pretty inelastic. But is it perfectly inelastic? I don't know. They may be able to find ways to get a few more seats on the field, depending on how high that incentive is and how much people are willing to pay to get on that field.